All right, welcome back, everybody. This is my second attempt. My first attempt got disturbed by something. Anyway, here we are, second attempt. We are going to look at categorical logic today, and I know I said I was going to do the whiteboard again, and I will. Once we start practicing doing categorical logic, I will go back to this. But I realized that it would actually be good to use my slideshow just to introduce it because there is some stuff that we can do that way that'll make it a little bit more clear. So that's what we're doing today, categorical logic. You've done propositional logic, right? And the main task that I gave you in this shortened version of the class, right, is just can you determine if an argument is valid or invalid using either the truth table method or the short method, right? But that's the game. You're trying to figure out is the argument valid or invalid. Categorical logic, same game, right? We play differently, but it's the same thing. We're just trying to figure out with these types of arguments where the premises talk about categories of things. I'll show you what that means in just a second. Right? With those types of arguments, we can use a different technique than the truth table technique or the short method, right? It's a more visual technique. We use these circles to represent different categories, and that allows us to represent an argument visually. And then you can see visually if the argument is valid or invalid. It's much more direct, right? For propositional logic, you're looking for a gremlin, and the gremlin tells you that it's invalid, right? It's kind of indirect, making sure there's no gremlins. Here, we'll see it directly. If the premises are true, right, you just kind of put the premises onto the circles, and then if the argument is valid, then the conclusion has to be true, and the conclusion will just reveal itself in the circles. I know that sounds kind of magical, and it is, but you'll have to wait to see what I mean by that. Right? So in propositional logic, you have to get used to those four operators, right? Conjunction, disjunction, conditional, negation. We saw that a lot of arguments have conditionals, if A, then B, right? So, we can use those patterns and those operators, those concepts of conjunction and disjunction and negation, right? And when we can create valid arguments with them, right? And then we can use propositional logic to check for validity. But there's other types of arguments as well that don't use those specific operators in the same way, like this argument, right? You should be able to tell that this is a valid deductive argument, right? All humans are mammals. No mammals are cold-blooded creatures. Therefore, no humans are cold-blooded creatures. Hopefully, everyone sees, has the logical intuition, right? That conclusion, that follows logically, right? It's a valid inference you can make. If it's true that all humans are mammals, and if it's true that mammals are not ever cold-blooded creatures, then it follows that no human is cold-blooded, right? It just logically follows. But here you'd have to reword it if you wanted to use the truth table method, right? Or the short method. You'd have to say, like, if something is a human, then it is a mammal, right? And if something is a mammal, then it is not a cold-blooded creature. You have to translate everything into propositional language, right? Well, we don't have to do that. We can simply use categorical logic instead, right? As long as it's an argument that talks about all or none, or as we'll see in a minute, some, right? Those are all talking about categories of things, right? You can think of humans, mammals, cold-blooded creatures. These are all multiples of something, right? Plural nouns. All categorical logic arguments are going to look like that. They're always going to look like this, with two premises and a conclusion, and then there will be three categories of things. Right? So you can think about categories like a big circle, right? Let's gather up all the humans and put them all in this circle. And then we could say something about all of them, right? Or we could say something about some of them, or we could talk about none of them, right? So we can create these categorical type of statements like premise one and premise two, and that allows us to infer another categorical statement. Another example, here we see some, right? Some humans are cheaters. All cheaters are liars. Some humans are therefore liars. Right? So again, we can imagine, right, circles with all the humans inside, circles with all the cheaters inside, circles with all the liars inside, right? And then sometimes there will be overlap, right? So if it says some humans are cheaters, it means that some of the members of this category of humans are also in the category of cheaters. I like to think about categories as clubs, right? We all belong to the human club. And well, some of the people that belong to the human club also belong to the cheaters club, right? And guess what? Everyone, according to premise two, everyone in the cheaters club is also in the liars club, right? So I hope you kind of see how this works. With some, all, and none, you can create these kind of categorical arguments, and we use categorical logic to determine validity. Right? So that part doesn't change, right? We're still trying to figure out, is the argument valid, right? And how can I figure that out? And in categorical logic, we figure it out with the circle system. All professors are boring people. No boring people are likable people. Therefore, no professors are likable people. Well, I don't like that argument particularly much, but I will admit that it's a valid argument, right? If the premises are true, then the conclusion logically has to be true as well, right? We could translate it into propositional logic if we wanted to. We could do a truth table, and we'd figure out that in any world where the premises are true, the conclusion is also true, right? But we don't want to do propositional logic now, right? We want to do categorical logic so we can use a different technique for determining validity. Well, I can tell you this argument is valid. Whether it's sound is a whole other question. I hope you can keep that in mind still, right? That we have two tests that an argument has to pass. Any argument, whether it's deductive or inductive, it always has to pass both of the tests, right? One is the truth test. Are the premises true? Is the information that you're providing to as evidence for your stance, is that actually accurate? Right? Does that reflect reality? And that's the truth question. The logic question is, do the premises support your conclusion? Do they actually provide reasons for thinking that the conclusion is true? And in a deductive argument, the premises are supposed to provide incontrovertible, right, evidence that the conclusion is true. If the premises are true in a valid deductive argument, then the conclusion must be true. In an inductive argument, the support is different. Their premises can support a conclusion in a probabilistic way, right? So in a strong inductive argument, if the premises are true, then the conclusion is probably true. Right? But we're still talking about logical support, right? Do the premises support the conclusion, either deductively or inductively? Right? So the truth question and the logic question. This argument right here passes the logic test. Right? It passes the logic question. I like to think it doesn't pass the truth test, right? So it's not sound. So ultimately, it's not convincing. Any argument, for it to be convincing, has to pass both. It's useless for an argument that's just valid or that just has true premises. That doesn't matter. We need both, right? The information has to be correct and the inference has to be logical. So they're valid. They don't use the same operators though, right? They make statements about whole groups or categories of things, right? So you can, again, imagine we're talking about all the members of a certain category, or maybe about some of them, or we're saying something about none of them. Right? So these are all like that. These are all categories: humans, mammals, cold-blooded creature. Right? Anytime you have a noun with a plural, like with an S at the end of it, we're talking about categories of things. Right? Now, some categories only have one member. Right? That can't happen. Right? So if you want to talk about an individual person, like we used to talk about, Socrates is human, right? Here you'd have to say something like, all persons identical with Socrates, right? That's a small category, but it's a category of thing, and it has one member, right? If we're talking about that Socrates. And they always talk again about it involves all, some, or none. And that's again easy to imagine, right? You have a circle with a bunch of things in it, right? Maybe we're talking about none of them, right? Maybe we're talking about all of them. Maybe we're talking about some of them. All humans are mammals, right? It says all members of the group or category of human is also part of the group or category of mammals. Right? Or to put it into the club language that I like, right? All members of the human club are also members of the mammal club, right? And we could sort of imagine this as there being overlap. That's, I'm in this circle, the human circle, but I'm also in the mammal circle, right? Or some, right? Some humans are cheats or cheaters. And so that's saying that there's some members of the group human who are also members of the group cheats, right? So get used to this way of thinking, right? That we're talking about members of a category, members of a group, members of a club, as it were. And then we're comparing one group with another, right? We're saying all of these are also in this club, or some of these are also in this club, or none of them are in this other club. Right? We can create all sorts of statements that way. And all sorts of arguments. Here's the category of professors and the category of likable people. Right? And it's saying there's no overlap there at all. Right? That's what it's saying. That if you're in the category of professors, you're not in the category of likable people. Right? That's the way this works. So that's what categorical logic is all about, making valid inferences with these kind of group category statements, talking about some, all, or none. So like with propositional logic, right, the basic ideas are pretty straightforward and they're things we already know. We already can think categorically. We have an intuitive understanding. It's just sometimes it's difficult, right? Some examples it's easy, right? If I say all humans are mammals, all mammals are warm-blooded creatures, then it just pops out. Okay, that means all humans are warm-blooded creatures. Other arguments are more tricky. We can't just detect it with our intuitive logic sense. We have to do some categorical logic. We got to do the circles. So just like we had 4 operators in propositional logic, here we have 4 different types of statements that we can make in categorical logic. And I mean this, that's going to be all of them, right? So categorical logic arguments are always going to look the same. They're always going to have 2 premises, exactly 2. Remember, in propositional logic, you could have a million premises or just one. In categorical logic, we always need exactly 2 premises and then a conclusion. And there's always going to be just 3 categories of things, right? That's why we see the 3 circles, because there's going to be exactly 3 categories, right? So we have 2 premises that talk about each of these 3 categories, and then that allows us to make an inference. So here's a little bit of technical stuff that you should try to memorize, just to have the terminology and the concepts in your mind, right? All SRP, right? Like all humans are mortal beings. Here we're saying something about all the members of a category, right? And then no SRP, in a way, we're still talking about all the categories, but we're talking about it in a negative way. So like, no politicians are honest people. Okay. It's probably not true either, but it seems like it sometimes, doesn't it? Some SRP, some people are hard workers. And by the way, because this is logic and we can't have any ambiguity, we have to define our terms sometimes. And this is kind of weird, but in logic, when we say some, it means at least one. That's all it means. So some could be just one. Right? So when we say some people are hard workers, that could mean there's just one person that's a hard worker. That doesn't seem correct, but that's just what we mean by some. It means at least one member of this category. Or some S are not P. Some citizens are not taxpayers. So every single argument that we're going to look at, that I'm going to have you practice on, that you'll be tested on, every single categorical logic argument will have premises and a conclusion that looks like one of these four. There's slightly different ways that you can phrase things, but they always reduce back to one of these four. So you're always going to have one type of premise, another type of premise, that's one of these ones, and then a conclusion, that's one of these ones. Okay, so I think that's helpful to remind yourself that it's not going to get all that complicated, really, right? You're just dealing with one of these types of statements at a time, right? And a premise will have three total statements, two premises, one conclusion. Each of those statements will match one of these categories. And let's give them names. Right? So the first one, we're saying something affirmative and positive about all the members, right? It's a universal affirmative. We're saying all the members, yes, they have this truth about them, right? They also belong to this category, or they don't belong to that category. Whatever it is, we're talking about all of them in an affirmative, positive way. All S are P. All humans are warm-blooded creatures. Or we're still talking about all the members, but we're saying it in a negative way, right? So it's a universal negative. No SRP, no humans are cold-blooded creatures, unless you mean metaphorically, and then I've met a few. Some SRP, that's again affirmative, but now we're talking about particular, and not all. We're talking about some. Right? So then we're talking about particulars, not the collection of all of them. And then particular negative, right? Some S are not P. So once again, for all the arguments that we're going to have you look at, that you have to use categorical logic to figure out validity, right? To figure out if the argument is valid or invalid, each premise and conclusion will match one of these types of statements. So just to make sure you get this, I'm having you do a very easy exercise. This should be super easy and super fast, but I just want to make sure that you understand every little step from the get-go. And it looks like people are doing pretty well. People who have turned in the midterm have been doing pretty well. I feel like they've gotten, you knew how to do the valid thing, so how to check for validity. So that's good. So hopefully this will make as much sense, if not more, than propositional logic. I think some of you will really like it if you're a visual type. Right? That's the nice thing about this way of doing it. Okay, so just laying the foundation here. All right, just to recap, so you're crystal clear on what we've said today so far. You can create deductive arguments, not just the way propositional logic does it, but you can also do it like this with categorical statements. All, some, no. And there's four basic types that you should know about. Right? The universal affirmative, all mammals are warm-blooded. Right? Universal negative, no humans are cold-blooded. Right? Particular affirmative, some humans are cheaters. Particular negative, no human is cold-blooded. Okay. Sorry. Some humans are not cold-blooded. Right? That's what I meant to say. It's a particular negative. Right? Anytime you have particular, it's some. Universal, it can be either all or none. Just a little bit more vocab, just to make sure you understand each part, so that when we talk about it later, you know what I'm talking about. All doctors are graduates. Hopefully you know right away, right? This is a universal affirmative. If it says all or no, it's a universal, right? And if it doesn't say not, then it's affirmative. So this statement here, all doctors are graduates. The main thing it's talking about are doctors, right? The statement is saying something about doctors. So doctors are the subject of the whole statement, right? They're the main star, right? We're saying, here's doctor, and here's something true about doctor. So doctors is called the subject term, and graduates is the predicate term. So for any of these category type of statements, the first thing that comes right after the all, some, or no is the subject term, and then the second thing, whatever the sentence ends with, right, is the predicate term. Because we're predicating something of the subject. That means we're saying something about the subject. And the fact that we're saying something about something makes it a subject. So all categorical statements are like that. They're all going to have the same basic type of shape. This is not as important, but since we're breaking down the whole categorical statement, are or is not or are not is called the copula, right? They hold two things together. We do get the word copulate that's related to that. Right? So in particular negatives, the copula is are not. Now this might sound confusing at first until you see a nice little diagram, right? This hopefully helps. You can see that it's just the same thing every time. We have four basic types of statements, right? The universal affirmative, universal negative, particular affirmative, particular negative, and that's what each of these represents. And then you can break them down in terms of the subject. That's whatever comes right after the all, no, or some. And then there's the predicates, and so both of those are categories of things, right? So both of those will be circles, right? So all diamonds, that's one category of things. Are precious gems, that's another category of things. And then the are and are not is just sort of like what joins them. It's like a conjunction type of a thing, right? You don't need to worry too much about the copula. What we really are focused on is the subject and the predicates. Okay? So do that here. This should, again, be super easy, but I just want it to be, just entrenched in your mind, the idea of the subject and the predicates. So making you do this will make sure that you understand what we're talking about when I say subject, predicate. Now, here's something that we would do if the class was longer. We're going to skip anything about distributed or undistributed. So I'm going to skip right over this. There's an exercise in here that we don't need to do. This is just a little bit more, if we had time, we would do it, right? But we don't need to, because if I'm focusing just on determining validity, then there's some of the stuff that we don't need to worry about too much. So I'm just going to skip over all this, okay? You can look over it if you want, but ultimately it won't be necessary for what I'm going to have you do. Right, so you do not need to do this exercise. I didn't label it. Don't do it. And now we get to the real stuff, the real real machinery of how categorical type of arguments work. Okay? So first, we'll just think about representing a single category or a single group or a single club. Right? Then we'll think about how to create a categorical statement using two circles. Because remember, every categorical statement has a subject and a predicate. It always looks like that. So there's always going to be two categories involved for a statement. And then for an argument, there's always going to be three categories total. That's why for representing a single category, you just need one circle. To represent a categorical statement, where you have a subject and a predicate term, which are both categories, you need two circles. For an argument, arguments are always going to have three categories. And so you'll need three circles. So we'll start with one, then two, then three. And once you understand, once you're at the level where you can represent two different statements onto three circles, then you'll be ready. Right? You'll actually have learned it already at that point, because that's all you end up having to do with this type of thing, right? You'll look at a categorical argument. You'll see, make sure it's got two premises and a conclusion. Make sure it has just three categories, and then you can just make the three circle construction. And I'll teach you how to do this. You will plug in the premises. Right? You'll represent just the premises. You don't even touch the conclusion. You just take the premises and put them into the circles. You don't know what that means yet, but I'm just telling you that that will be the procedure. We'll just represent the categorical statements, the two premises, in the three circle diagram. Then you're done. Then you just look at it and ask yourself, does this also now represent the conclusion automatically? If it's a valid argument, the conclusion will just have been represented. Just by representing the premises, the conclusion will also be represented. That tells us the argument is valid, right? It shows that it's logically impossible for the premises to be true and the conclusion to be false. If it doesn't show up, then it's invalid. Again, you don't really understand what any of this totally means, but that's the procedure, right? So I'm just telling you, it's all about learning how to represent the premises onto the three circle construction. And once you know how to do that, you know what to do. I'll show you. That's the magic of categorical logic using Venn diagrams. Is you figure out a way to represent the premises, and then you put your pencil down and you just look at the results. And you look at the diagram and you try to see, is the conclusion now there? If your argument format was valid, then just by representing the premises, you will also have already presented the conclusion. So that's very different from propositional, right? In propositional logic, you have to translate everything, the premises and the conclusion. You got to write the whole thing out. Here, you don't ever try to represent the conclusion. You only put the premises into the circle. Then if it's valid, the conclusion just magically shows up. So let's start really simple, right? Let's say we're not making a categorical statement. We're just talking about a group of things, right? A category, right? A club, the Squirrel Club. Well, all you need to do to do that is just this, right? That's it. Make a circle, write the name of the category underneath it. That's it. And now you've represented squirrels. And notice you don't have to put anything into the circle. If it's white like that, if it's not blacked out, it's basically just saying here's the space for squirrels. You don't have to write the squirrels in there, right? We'd say here's a circle, and if there's any squirrels at all, this is where they go. So in a way, it's not even saying that squirrels exist. Right? It's just saying here's the category, here's the circle that they would go into. Later on, we'll learn the blackout technique, and once we put black in the circle anywhere, it means nothing is in there, right? Nothing at all. So if it's just white, it just means that's where all the members go. So this tells us it's just a circle with nothing in it. That means this is the club for circles. Oh, sorry, the club for squirrels. Circles and squirrels are very close. You could make a category of circles, of course, right? You could do that. Okay, so this is easy. So you can do this for any category, right? You just sort of write the category, make a circle, right? Okay, that should be very easy. Hopefully no one's having a hard time with that, right? But remember, for any categorical logic argument, it's going to look like one of those four types of statements: universal affirmative, universal negative, particular affirmative, particular negative. Those four. That's all we're going to deal with. For any of these arguments, every premise, conclusion is always going to look like one of those four. So you should learn how to represent those. and then you'll almost know how to do categorical logic, right? Seriously, it's once you get it, it's so easy. Right, so just as a reminder, right, these are the 4 different types of statements that we're going to be dealing with. And it's kind of nice, right? You had 4 operators, and here we have 4 types of statements. So that's like the version of the pieces of the game, right? The pieces of the game are just those 4 statements. You have to learn how to represent those 4 statements. And we have a technique for that, right? So remember, any of those statements always has a subject term and a predicate term, right? So we make 2 circles, one for the subject, one for the predicate. And we'll always put the subject on the left, predicate on the right. Just it's the same way as we read, right? We read from left to right. So if I say all doctors are scientists, whatever, then we have doctors being subject, scientists being predicate. And by the way, sometimes you might come across a categorical argument that isn't phrased really correctly. So for example, if I say all humans are mortal, that's not really right? Mortal is an adjective. Right? We need this to be countable things. Right? So I'd have to say something like all humans are mortals, right? Or all humans are mortal beings. Right? So sometimes you just have to turn an adjective into a thing. Right? All children are curious. Right? That's not really a categorical statement yet. It needs to be something like all children are curious beings, something like that, right? We always have to make sure that we're talking about categories of things that we could potentially put into a circle. So if our statement is all squirrels are omnivores, it's a nice universal affirmative, right? We're talking about all squirrels and we're saying something positive. All squirrels are omnivores. So you start with the subject term, right? Squirrels on the left, and then right to the right of it, but overlapping, this is important, it's got to overlap because that allows us to say different things about the relationship between the 2 categories. Because that's what each of those 4 statements represents, right? The universal affirmative, universal negative, particular affirmative, particular negative, they all are saying something specific about the relationship between the subject category and the predicate category. And so this gives us the vocabulary for that, or the syntax for this. So this is where you start. For any categorical statement, it doesn't matter. We chose universal affirmative. It doesn't matter which of the 4. You could always start like this. 2 circles, one for the subject, one for the predicate. Right? Subject on the left, predicate on the right. Now here's where the technique comes in. I told you earlier, right? The white clear represents things can be in the circle. Right? Blacked out means there's nothing there. There's no beings at all, right? Black out means void, death zone, right? Nothingness, the abyss, darkness, nothing. So we just black that all out. So now it means that if you're a squirrel, and all squirrels have to be inside the squirrel circle, if you're a squirrel, there's nowhere else for you to be except for that little sliver in the middle. Because squirrels are not anywhere outside the squirrel circle ever, right? They're always inside the squirrel circle. They also can't be in the omnivore circle in the big area, because that's outside of the squirrel circle, right? So all squirrels are going to be in that circle, but the blackout means there's nothing there. There's no squirrels there at all. So now this tells us that if you are a squirrel, you are also an omnivore, right? This represents if you are part of the squirrel club, you are automatically part of the omnivore club, right? Because we've represented it that way. And so you just black out the area where squirrels cannot be. Right? If it was open, then maybe there's a squirrel that's not an omnivore. But right now we're trying to say, if you're a squirrel, you live inside the squirrel circle, you can't be in the black area, so you got to be in that little sliver in the middle. That then tells us all squirrels are omnivores. So any universal affirmative is going to look like this. You can write different words underneath instead of squirrels and omnivores, but if it's a universal affirmative, it's always going to look like this, right? So this is your first sort of technical thing. This is like defining one of the connectives of the truth table, right? There's 4 connectives, and you have to memorize the truth tables for them. Well, here we have 4 types of categorical statements, and you have to memorize how to represent them. So it might seem weird to you at first, but it helps if you can really imagine what the logic of the visual is, right? So it really helps if you can understand squirrels, right? If it's a squirrel, if we have a circle that says squirrels underneath it, we're sort of saying all squirrels exist inside the circle. If there's an area that's blacked out, that means there's nothing there. So this tells us, like logically, right, that's if you're in the squirrel circle, you got to be in that little sliver that overlaps with omnivores. So it sort of pushes the squirrels to automatically be part of the omnivore circle as well. If the logic of the visual doesn't make sense to you intuitively, at least just memorize. Right? This is what a universal affirmative looks like. So again, every categorical logic argument will have 2 premises and a conclusion. Each of the premises will be one of those 4 types of statements. So the premise might be one of these, right? And then this is how you'd represent that premise. It's always going to look just like that. Any all SRP statement will look just like this. And it tells us if you're a member of the category S, you cannot be in the black area. The black area means death. Nothing lives there. If you're a member of the category S, you are in that middle wedge. And that middle wedge represents an area where you're both in the S club and in the P club. Okay, what about a universal negative, right? No SRP. No cats are humans, let's say. We use the same blackout technique. For any of the universals, remember this, for any of the universal, you black something out. For the universal affirmative, you black out the whole left area. Here, we black out the wedge area. But you always start the same way first, right? Like I said, this is true. No matter what type of statement you're categorizing, you start like this. What is the subject and the predicate? Subject first, predicate next. Cats, humans, overlap. Okay. Then if we want to say something about the relationship between cats and humans, which in this case is no cats are humans, we want to visually see that if you're a cat, you're in the cat circle, you can't possibly be in the human circle. And we can do that by blacking out the middle area like this. So once again, an open circle, white, this means that's where all the members are, right? All the members of the cat circle are outside of the human circle. The area where there's overlap is blacked out, right? So there's no cats at all that are also hanging out in the human circle. Right? The black area represents that fact. So if you're a cat, you must be in the cat circle, but outside, entirely outside of the human circle. This again should make intuitive sense visually, right? Just understanding that the black here represents nothingness. There's nothing there, right? So that just means there's nothing that's both cat and human, right? That's what this is showing. And so all universal negatives, anything, right? It doesn't have to be cats and humans. We could be talking about anything at all. As long as that has that general shape of no SRP, this is how it will be represented, right? If you're a member of the S club, if you're in the S circle, you are not in the P circle. You're not a member of that category. So that's two of them so far, right? Blackout on the left, blackout in the middle. Universal affirmative, universal negative. Now, what about particulars? Some dads are grill masters. Right? First step is always the same. You make the two circles that overlap, label them dads, grill masters. Now, we want to say there's at least one member. Right? That's what some means. Some means at least one member. And so we can just represent at least one member with an X. An X means at least one member. So now we can say there's at least one dad who's also a grill master. There's at least one dad who's also a grill master. In other words, some dads are grill masters. I know this might be a stumbling block for some people. The fact that some in everyday English usually means more than one, right? It's just one of these things you have to get over. Right? One is not special here. All we care about is there something true about some of the group but not all, and that could just be one, or is there something true about all of them? Universal versus particular. For any of the universal, we use the blackout technique. For any particular, we put an X somewhere, because X means some, at least one. So if you look at the diagram, right, the black represents an absence, right? You can't put any members here, therefore it's a universal affirmative or universal negative. Here, X represents the presence of something. The presence of what? Of some, which here in logic means at least one. So any particular affirmative looks like this, right? X means at least one, right? At least one member. So this is telling us that there's at least one guy, right? At least one. And you can just think in your mind. If that's too confusing, you can say at least one, but probably more, right? Most of the time when we say some, it means more than one, right? But because we have to be very precise, we have to just define it as at least one. Right? So this just tells us there's an X, there's at least one being who is in the S club as well as in the P club, right? In other words, some SRP. Last one, and then I'll stop the presentation after that, and we'll get back probably tomorrow. What about a particular negative? Some books are not bestsellers. Right? It's particular, some, but we're saying it's not part of this other category, right? So there's some members of the category books who are outside of the category of bestsellers. You should be able to predict how this is going to look. With the logic of the previous one, you should know what it's going to look like. Okay, first step, of course, always the same, right? The two circles of the two categories. And then X means at least one member. What is some books are not bestsellers saying? It's saying there's at least one member of the book circle that's not inside the bestseller circle. So that means we're going to put an X outside of the bestseller circle, but still inside the book. So now we've represented there's at least one book that's not a bestseller. And that's just another way of saying some books are not bestsellers. So I hope you can get over the hang up of some meaning at least one. Just think of it as this is technical vocabulary. You don't have to change the way you talk normally, right? Normally some means a bunch, right? It means more than one, usually. In logic, we're just defining it technically as at least one. So just remember that. And that's just what particular negatives are always going to look like, right? If we want to say that a member of one category, there's at least one that's not a member of the other category, you put an X inside the subject term and outside of the predicate term. So that's it. That's all four of them. So every single argument is going to have premises that will match one of those four. Every single premise of arguments that I'm going to have you figure out validity for will be one of these, right? And so next time what we'll look at is how to combine two statements. Here we have individual statements, but in an argument, we're going to have two statements because we're going to have two premises. But since every categorical logic argument only has three categories, it means we only need three circles. So we'll learn how to put three circles and then use these same rules to represent the premises. Okay? So I'll show you how to do that next. First, just kind of practice this, get used to this, try to understand the visual logic of the blacking out technique and the writing an X technique to represent these different types of statements. Okay? So just as review, we're doing a brand new type of logic, categorical logic, where categorical logic arguments always have two premises and they make some sort of categorical statement, either all S are P, no S are P, some S are P, some S are not P. Right? And then when it comes time to evaluate an argument, we're going to learn how to get three circles and use this symbolism to represent the premises inside of our three circle construction. And that is going to allow us to determine validity. You have not learned how to do that yet, right? This is just the ground rules here. We're just getting started. Okay, I'll see you soon.